All right, let's talk about a really pivotal moment in Wi-Fi history, a time when the push for more speed literally created a fork in the road, splitting the next generation of Wi-Fi into two totally different competing paths. We're talking, of course, about 802.11a and 802.11g.
Now, before we really dive in, I just want to set the stage. This is part 5 of a much larger 20-part series. It's all based on a super detailed report from the RFI detectives. They're part of Virtualization Options, LLC. And for today, we're zooming in on Chapter 5, specifically with IT pros like you in mind.
Okay, so to really get why things went the way they did, we have to rewind the clock. Let's go back to 1999 and look at the massive problem that wireless engineers were just wrestling with.
11 megabits per second. That's it. That was the absolute top speed you could get from the first really widespread Wi-Fi standard, 802.11b. I mean, it was revolutionary for its time, no doubt. But as you can imagine, with applications getting more and more demanding, 11 Mbps quickly went from being amazing to being a serious bottleneck.
So everyone was screaming for more speed, a real breakthrough. But the answer? Well, it wasn't a simple, straightforward upgrade. Not at all. The path forward actually split, forcing network engineers to make a really big decision. So instead of just one clear next big thing to replace 802.11b, we got two. Two new standards that came out at almost the exact same time, 802.11a and 802.11g. And here's the kicker. They both had the same goal, but they took completely different roads to get there.
And what was that goal? A massive jump in speed. We're talking 54 megabits per second. That's almost 5 times faster than the old standard. So everybody agreed on the destination. The big disagreement was, how do we get there?
And it all came down to one crucial decision: what radio frequency to use. On one side, you had 802.11a, which made this bold jump to the brand new wide-open 5 GHz band. On the other side, you had 802.11g, which played it safe and stayed right where it was, in that familiar but super crowded 2.4 GHz neighborhood. And that one choice, man, it had a ton of downstream effects.
All right, so let's get into the nitty-gritty. Let's really put these two standards side by side and see what the trade-offs were.
Okay, so this table really tells the whole story. You can see they both hit that target of 54 Mbps. But look at that last row, backward compatibility. This is the big one. 802.11 over in the 5 GHz band, nope, zero compatibility, with all those 802.11b devices already out there. But 802.11g, because it stayed in 2.4 GHz, was compatible. Now that sounds great, right? An easy upgrade? But that convenience came with a very real hidden cost.
And this is where we get to something that every network pro needs to understand. That decision, that choice to be backward compatible, it came with a pretty nasty performance hit, one that a lot of people didn't really get at the time, and it could drag down the whole network.
So here's the deal, and it's a huge takeaway. Wi-Fi is what we call a shared medium. Think of it like a conversation, where only one person can talk at a time. If you had even one old, slow 802.11b device connect to your shiny new 802.11g network, the whole conversation had to slow down to its level. That one slow client would just hog all the airtime, making all the fast devices wait their turn. The result? Performance for everybody just tanked.
But, for all their differences, there was one piece of revolutionary technology that they both shared. It was really the secret sauce that made that 54 Mbps speed possible in the first place. And it's a technology that's still at the heart of the Wi-Fi we use today.
And that game-changing tech is called orthogonal frequency division multiplexing, or just OFDM. The big idea here is, instead of blasting all your data out on one big radio wave, which can get messy, OFDM is smarter. It splits the data up into a bunch of smaller signals and sends them all at the same time in parallel. This makes the whole thing way more resilient to interference.
This quote right here, it nails why OFDM was such a massive deal. The biggest headache for Wi-Fi inside a building is something called inter-symbol interference. It's a fancy term, but all it means is that your Wi-Fi signal is bouncing off walls, ceilings, you name it, creating all these echoes that just garble the data. Well, OFDM was designed from the ground up to solve that exact problem, which is why it made connections so much more stable and reliable.
And so what this whole 802.11a versus G era really did was set up this fundamental debate that wireless engineers are still having today. It's the classic trade-off, right?
Do you go for a clean break, jump to a new, cleaner spectrum to get the absolute best performance possible? Or do you compromise and stick with the old ways to make sure everyone's older gear still works? It's a question that defined the past, and it's still shaping the future of wireless right now.